In this video, we're going to create our board manager script, which is going to procedurally generate our levels so that they're different each time the player plays. We're going to start by creating two empty scripts, our board manager and game manager scripts. We'll choose Create, C# script, call the first one board manager, and call the second game manager. We'll also create an empty game object called Game Manager. Let's start by adding our level generation code to Board Manager. We'll open it in MonoDevelop. The Board Manager script is going to lay out our randomly generated levels for us each time the player starts a new level based on the current level number. The first thing that we're going to add is a namespace declaration using system. We're going to do this so that we can use the serializable attribute. Using serializable just allows us to modify how variables will appear in the inspector in the editor and to show and hide them using a foldout. We're also going to add using system.collections.generic so that we can use lists. Finally, we're going to include using random, and we're going to set that to equal unityengine.random. We need to specify this because there's a class called random in both the system and Unity Engine namespaces. In our class, we're going to start by declaring a serializable public class called count. In count, we're going to declare two public variables called minimum and maximum of the type int. We're also going to include an assignment constructor for count so that we can set the values of minimum and maximum when we declare a new count. We're going to give it parameters, min and max, which we're going to use to set the values of minimum and maximum. Next, we're going to declare our variables. We'll start with our public variables. The first two will be an integer for columns and an integer for rows. These will delineate the dimensions of our game board and will allow us to make our game board larger or smaller by changing them if we want to. In this case, we're going to initialize them each to 8, meaning we're going to have an 8 by 8 game board. Next, we're going to use count to specify a random range for how many walls we want to spawn in each level. In this case, this means that we'll have a minimum of 5 walls per level and a maximum of 9 walls per level. We're going to do the same for our food items. Next, we're going to declare some variables to hold the prefabs that we're going to spawn to make up our game board. We're going to have a single game object called exit because there's only one exit object. For our other objects, we're going to use arrays so that we can pass in multiple objects and then choose one of them that we want to spawn among the variations. Let's start with floor tiles. We'll also do the same for wall tiles, food tiles, enemy tiles, and our outer wall tiles. We're going to fill each of these arrays with our different prefabs to choose between in the inspector. Next, we're going to declare a couple of private variables, including a transform called board holder. Board holder is just something that we're going to use to keep the hierarchy clean. Because we're going to be spawning a lot of game objects, we're going to child them all to board holder so that we can collapse them in the hierarchy and not fill our hierarchy with objects. We're also going to declare a private list of vector 3s called grid positions. We're going to use this to track all of the different possible positions on our game board and to keep track of whether an object has been spawned in that position or not. Next, we're going to declare a function called initializeList that's going to return void. In initializeList, we're going to start by clearing our list of grid positions by calling the clear function on our list. Next, we're going to use a pair of nested for loops to fill our list with each of the positions on our game board as a vector 3. We'll start with the x-axis. So this first loop is going to run for as long as x is less than our number of columns, -1, and then we're going to do the same along the y-axis inside that. Inside that loop, we're going to add a new vector 3 with our x and our y values to our list grid positions. What we're doing here is we're creating a list of possible positions to place walls, enemies, or pickups. The reason that we're looping from 1 to columns -1 is so that we can leave a border of floor tiles directly within the outer walls. This is going to mean that we're not going to create completely impassable levels. Next, we're going to declare a new private function that's going to return void called board setup. We're going to use board setup to set up the outer wall and the floor of our game board. We'll start by setting board holder to equal the transform of a new game object called board. Next, we're going to use the same type of loop pattern to lay out the floor and the outer wall tiles. So we're going to use another for loop along the x-axis and along the y-axis. The reason that each of these loops is going to go from -1 to columns +1 or to rows +1 is because we're building an edge around the active portion of the game board using the outer wall objects. Next, we're going to choose a floor tile at random from our array floor tiles and prepare to instantiate it. So what we're doing here is we're declaring a variable of the type GameObject called toInstantiate and setting it to equal an index in our array of GameObjects called floor tiles, which we're choosing randomly between 0 and the length of the array floor tiles. This means that we don't have to pre-specify the length. We can just take the length and choose a number within that array. Next, we're going to check if we're in one of the outer wall positions, and if so, we're going to choose an outer wall tile to instantiate. So we're going to check if x is either equal to -1 or our value for columns, or y is equal to -1 or our value for rows, and if so, we're going to set toInstantiate to a randomly chosen tile from our outer wall tiles array. Once we've chosen what tile we want to instantiate, we're actually going to instantiate it. So we're going to declare a variable of the type GameObject called instance, and then we're going to assign that to the object that we're instantiating. So we're going to call instantiate, pass in toInstantiate, the prefab that we chose, at a new vector 3, which is going to be based on our current x and y coordinates in the loop, and we're going to pass in 0 for the z-axis because we're working in 2D. Quaternion.identity just means it's going to be instantiated with no rotation, and we're going to cast it to a game object. With that done, we're going to set the parent of our newly instantiated game object to board holder. Board setup is going to lay out our outer wall tiles and our background of floor tiles. What we're going to do next is we're going to start writing some of the functions which are going to place the random objects on the game board, like walls, enemies, and power-ups. We're going to declare a new function that returns a vector 3 called random position. In random position, we're going to declare an integer called random index and generate a random number within a range for that. The range that we're going to generate the number within is going to be between 0 and the number of positions stored in our grid positions list, which we're accessing using gridpositions.count. Next, we're going to declare a vector 3 called random position, and we're going to set it to equal the grid position stored in our grid positions list at our randomly selected index. To make sure that we don't spawn two objects in the same location, we're going to remove that grid position from our list. We're doing this using the remove@at command and providing the index random index. Next, we're going to return the value of random position so that we can use it to spawn our object in a random location. Now that we've generated a random position from our list and made sure that it's not a duplicate, we're going to write a function to actually spawn our tiles at the random position that we've chosen. This is going to be called layout_object_at_random, and it's going to take three parameters: an array of game objects called tileArray, a minimum integer, and a maximum integer. The first thing that we're going to do is we're going to declare an integer called object_count and initialize it with a random value between minimum and maximum +1. Object_count is going to control how many of a given object we're going to spawn, for example, the number of walls in a level. Next, we're going to write a for loop. We're going to repeat the for loop for as long as I is less than our object count, meaning we're going to spawn the number of objects specified by object count. We're going to start by choosing a random position by calling our random position function. Next, we're going to choose a random tile from our array of game objects, tileArray, to spawn. We're going to do this by generating a random number using random.range between 0 and tileArray.length. We're going to instantiate the tile that we've chosen at our random position. So we can delete our start and update functions and declare a new public function that returns void called setUpScene, which takes a parameter of the type int called level. And notice that setUpScene is the single public function in this class. This is the one that's going to be called by the game manager when it's time to actually set up the board. Within setUpScene, the first thing that we're going to do is call board setup. Next, we're going to call initializeList. We're going to call layout_object_at_random, and we're going to pass in our array of wall tiles and also our minimum and our maximum wall count values. Next, we're going to do the same for our food tiles. Instead of generating a random number of enemies, we're going to generate a number of enemies based on the level number using mathf.log to create a logarithmic difficulty progression. Mathf.log returns a float, and so we're going to cast that to an integer. This means that we'll have one enemy at level 2, 2 enemies at level 4, 3 enemies at level 8, and that the difficulty will continually scale up as the player ascends in level. Now that we've got the number of enemies we want to spawn, we're going to lay them out using layout_object_at_random. Note that the minimum and maximum values in this case are the same because we're not specifying a random range. Finally, we're going to instantiate the exit. The exit is always going to be placed in the same place and is always going to be the same object, so we're just going to call instantiate and pass in the prefab exit. The exit is always going to be in the upper right corner of the level, which is why we're using columns -1 and rows -1, and this means that if we choose to resize our game board, the exit will still be placed correctly. Let's save our script. Now that we've got our level generation code written in our board manager, in the next video, we're going to start writing our game manager and set up the game manager prefab.